Hello class, welcome back for week number 2, and I've noticed that most of you have been keeping up with your homework, so thank you very much, I appreciate that. We're starting to wind down chapter 8, but before we do, I have a supplement worksheet for you uh, that we're going to have for homework today. Before I get started though, I just want to remind you that if you're having any trouble at all, if you have questions, you need help, please don't hesitate to reach out. Email me, post a message in the Google Classroom, or let me know. I'm more than happy to meet with you for a Google Meet session anytime during the school day, either today or Wednesday or Friday. So just let me know how I can help. So today's homework is a worksheet that you'll find in the Google Classroom. I wanted to just offer you a few reminders and run you through a few examples that will help get you started. This is one of those assignments, again, that I probably would have given you a lot of class time to work on and work with each other, so don't hesitate to reach out to each other if you need to kind of talk each other through this. You can even meet together without me on the Google Classroom link anytime you want, or maybe you're just communicating with each other in other ways, but don't hesitate to do that. So the first thing you'll see in this assignment is number 1. There's several parts to number 1, and the directions ask you to determine the number of triangles possible in each case. So please be careful in here. It's not asking you to solve each triangle. It's just asking you to tell how many there are. And so for all of those, the answer will either be 0, 1, or 2. To help you get started with this, let me just kind of remind you of uh, the flowcharts that we had for the law of sines and the law of cosines, and in particular the ambiguous case. So two of the possibilities where we use law of sines are an ASS situation or an ASA situation. So that's when you have two angles and a side. Anytime you get one of those, you know the answer will be one solution. So you don't really have to do a whole lot of work. If you find this case, you shouldn't have to even set up the law of sines. Again, you're not solving. You're just recognizing that you either have AAS or ASA. If that happens, you know that you have one triangle and you're done and you can move on. If it's an SSA problem, that's our ambiguous case. That's the one that you need to be careful. It could be no triangles, one triangle, or two triangles. And I'm going to run you through just a couple examples here in a minute that maybe help remind you how to determine which of those it's going to be. So this is the case, the SSA case, that you really want to be on the lookout for when you do number 1. And then the other two cases are the SAS case and the SSS case. And those will be good news for you as well, because those are always just one case. So there's no ambiguous case for either side angle side or side side side. So these are the ones you would start by using the law of cosines. But again, on number 1, you don't actually have to use the law of cosines. We're not solving for any of the sides or angles. You're just telling me how many triangles there are. So if you get one of these cases, you'll just say 1. So like I said, let's just kind of look at a few examples here. The approach might be a little bit different today. You know, again, you're not solving for the triangles. We're just trying to figure out how many, so we could try to keep things as simple as possible. One thing I would do that I think would make things much easier is to draw a sketch. So on the worksheet there are no pictures of the triangles, but if it were me, I would draw just a very standard sketch. You know, don't worry about scale or anything like that. Just draw a triangle, label the angles A, B, and C, and then you could look at the values given and plug them in, and that will help you see which of these cases that triangle is. So on this one, they're giving you an angle A is 30 degrees, side A is 10, side B is 16. So if you plug those in, you should be able to tell rather quickly that this is an SSA, side angle problem. And since that's the case, that's the one that is our ambiguous case. And so that's the one we need to be very careful about. It could be 0, 1, or 2. And so this one you are going to have to do a little bit of work to figure out which one it is. So I've already done that work for you, if I can kind of talk you through it here. So this is one where we'd use the law of sines. So you would cross multiply, and this is one where you would need to use your inverse sine button to find angle B. And when you do that, you get an answer of about 53.1 degrees. So this is one of the things we looked at last week in our homework. Since it's the ambiguous case, you want to find what B2 might be. And the way you do that is that you find the supplement of 53.1. So if you subtract 53.1 from 180, you get 126.9 degrees. And since if you take that angle and you add it to the original 30 that was given, back up here, angle A, since those two angles add up to less than 180, that means there's enough room left over for there to be a third angle, which means that angle B2 case does work. And since that happens, that means there will be two triangles in this particular problem. You might recall, going back to this step, the reason we subtract 53.1 degrees from 180 is because two angles that are supplementary have the same sign. And so when you hit the inverse sine button back on this step on your calculator, it gives you one of those two angles. You might remember the range for inverse sine is between negative 90 degrees and positive 90 degrees. And so it's always going to give you the one answer that's between 0 and 90 in this case. It won't give you the answer of 126.9. So even though 126.9 is one of your answers, your calculator won't ever give that to you. So you have to find that on your own. And the way you do that is you find the supplement, and then again you check that, add that, take that number and add the 30 degrees that we knew from the given, and if that's less than 180, that means that second triangle does work. Here's another example where there's an angle and two sides given. This time, however, if you plug these values into this triangle, again, this is just a very just general sketch that I drew. Don't worry about scale or anything like that. But when I plug those numbers in, remember side C goes across from angle C, so that puts the 8 over here. And then the 5 is across from angle B. And then angle A is 36. So that makes this a side angle side problem. And side angle side is one of the cases where we use the law of cosines. And since it's one of those cases, that means there will only be one triangle possible. You should remember from geometry class that sine angle side is one of the properties that shows triangle congruence, and so that means that there's only one and only triangle that has those measures. And so this will be one that's pretty friendly in your homework. Anytime you find that you have an SAS or an SSS triangle, you can be confident that there is just one triangle for this case. One triangle only. I'm not going to do an SSS one in the examples here, but it would work very similar to this one. So again, anytime you find an SAS or an SSS, you can be confident that there's just one triangle. And you don't have to solve or anything, you just comment with one triangle, that's your answer, and you're done. Okay, here's one more example, given an angle and two sides. So again, if you just kind of draw a quick sketch, plug those numbers in, you see this is another SSA case. So once more, this is that ambiguous case that we spoke about a few minutes ago. And so we want to check to see if it's no solution or 1 or 2. And so I would set up your law of sines and cross multiply. And I've already done that for us. So set up your law of sines, cross multiply, and this time I got about 23.6 degrees for angle B. And in the same way, I'm going to subtract that from 180 to find its supplement, because that's the other angle that has the same sine value. And this time, however, when I take 30 degrees and add it to 156.4, I get a number that's greater than 180. So since that happens, that means there's not enough room left over for there to be a third angle. And so when that happens, that means there's only one triangle that exists. That's going to be my last example. I do want to mention, though, the one other case that I haven't talked about. Well, I guess, it's the SSA case that I haven't talked about. And that's the one case where you get no triangle. And remember, that's pretty easy to spot, because when you're on this step right here where you're cross multiplying, it will not give you an angle. Instead, it'll give you a domain error or some sort of error message on your calculator. And again, the reason that is because you're asking it to find the angle that has a sign that's outside of the range. So remember, the sign has to be between -1 and 1, and so most likely you're plugging in a value to your calculator that's greater than 1, and there is no angle that has that for its sign. So you will catch that right here on this step, on your very first cross multiplying step. If you get that domain error message, then you know that there will be no triangles. I wanted to offer just a couple more tips or hints or whatnot that can help you with today's homework. When you look at number 2, you might want to look at this chart. This is a chart that is found on page 538. I showed this chart to you on our first lesson last week and briefly looked at it with you. What it does is it helps you understand the ambiguous case and what happens that makes it so that there's no triangles or one triangle or two. And rather than introspection, which is kind of what we've been doing on the last few examples, what it does is it compares it to the height. And that's another way that you can determine how many triangles there are. And you can use this for number 1 if you want, but I would recommend that if you've been doing those the way that I taught in the lesson last week, I would just do number 1 like I just got done showing you. But this chart might be really helpful for you in number 2 because what it does is it gives you, I believe, one angle and one side, and it asks you to come up with the third side so that you either have 0 or 1 or 2 triangles. And so your job is to find this h value that third side either has to be less than to be none, or equal to be 1, or greater than to be 1. And then if that a value is between h and c, that means that's the time where there would be 2 triangles. So anyways, I just wanted to show this to you one more time. I think this chart here could really help you with number 2 in your homework. And then just a few other suggestions. When you get to number 3, it talks about a square and drawing a diagonal. So just in case you haven't heard that word diagonal a long time, it's just a segment that goes from one vertex of the square to the other vertex in the opposite corner. But more importantly, I think the second statement, a diagonal you can trust is going to be an angle bisector. So if we're talking about a square where each angle is 90 degrees, if the diagonal is an angle bisector, that means it's going to break it up into 2 angles of 45 degrees. And if you keep that in mind, I think that could really help you in number 3. I think drawing a sketch for number 3 can be extremely valuable as well. I think 5 and 6, while the numbers don't look friendly, they actually work out pretty nicely. And I don't think you're going to have a whole lot of trouble with, number 4 and 5, that is. And then when you get to 6 and 7, I think those are pretty friendly as well. Just wanted to remind you about the area formulas that we discussed back in lesson 8.4. So that was the assignment that most of you worked on in class the last day before spring break. So take a look at those. And then the last one, number 8, I would recommend drawing a sketch on that one. It talks about a parallelogram and the diagonals of that parallelogram. So I think one thing that could help with your picture, it talks about the shorter and the longer diagonal. And so the longer diagonal should be across from the larger angle, one of the inside angles of the parallelogram. So it should be across from the larger one, which happens to be an obtuse angle. And then the shorter diagonal should be across from the shorter angle, or the smaller angle, which would be an acute angle. And so when you draw your picture, if you kind of keep that in mind as you're trying to answer that question, I think that should help you out. So anyways, that's all I've got for you today. Good luck. Again, I know this is one of those assignments that is usually a little more challenging, and it would be nice to have a friend to work alongside with. So reach out to a friend, reach out to me if you have questions. Stick with it. It might take you a little bit longer than the others, and so you have a little bit extra time. This will be due Wednesday night, and so maybe you could do half of it Monday and maybe save part of it for Tuesday, just so you don't feel like you're sitting down spending too much time on it all at one time. So break it up. Take your time, reach out if you have questions, and good luck.